finding the x and y intercepts of a quadratic function. Much as we did in the application problems above, we also need to find intercepts of quadratic equations for graphing parabolas. Recall that we find the y-intercept of a quadratic function by evaluating the function at an input of 0, and we find the x-intercepts at locations where the output is 0. Notice in figure 13 that the number of x-intercepts can vary depending upon the location of the graph. So let's take a look at those graphs here. So here we have a vertex at 2, 1. Okay? And it looks like we have a y-intercept right here. But it doesn't cross the x-axis. So if there's no x-intercepts, then that means the x-intercepts are imaginary numbers. And we'll get to that later on. Okay, or imaginary zeros. So because it doesn't cross the x-axis, still means we have x-intercepts, but they will contain imaginary solutions. Now here it's going to have one x-intercept located at 2, 0. Okay, and then it has a y-intercept at 0, 3. The y-intercept here is 0, 5. Okay, so it has one x-intercept, but still it's a quadratic, so that means it's touching it twice. So what I mean by that is it's coming here, it's touching it, and then it's bouncing it back off. So basically it's bouncing off the x-intercept, so therefore you have one x-intercept. Now the next one, we have two x-intercepts. So here's one of them, and here's another. And we can see that it crosses the y-axis. So therefore here, the y-intercept could possibly be 0 and maybe 2.2. We're just approximating there. And then we have two x-intercepts. We have 1, 0, and then 3, 0. Now, given a quadratic function f of x, we want to find the y and x-intercepts. We're going to evaluate f of 0 to find the y-intercept. We're going to let x equal 0. And then we're going to solve the quadratic equation by letting f of x equal 0, letting y equal 0 to find the x-intercepts. So for example 7, find the y and x-intercepts of a parabola. Finding the y and x-intercepts of the quadratic function f of x, which is equal to 3x squared plus 5x minus 2. In step 1, we find the y-intercept by evaluating f of 0. So we're going to let x equal 0 and plugging it into the function. So we get 3 times 0 squared plus 5 times 0 minus 2. So we get 0 plus 0 minus 2, which gives us negative 2. So because we know that x is equal to 0, the y-intercept is going to be at 0, negative 2. Now to find the x-intercepts, we find all the solutions of f of x is equal to 0. So we're going to replace f of x in our function to be 0. So we're setting this entire equation, 3x squared plus 5x minus 2 equals 0. And when we do that, we need to factor this function in order to then solve for x. So we can factor this to be 3x minus 1 times x plus 2 equals 0. This is using the AC method. So there's some various videos that you can go back and check to find how to use the AC method. And so then we're going to use the zero product rule to set them both equal to 0. So we have 3x minus 1 equals 0, or x plus 2 is equal to 0. If we solve for x on the left, we get 1/3. If we solve for x on the right, we get negative 2. So the x-intercepts are positive 1/3, 0, and negative 2, 0. Now by graphing the function, we can confirm the graph crosses the y-axis at 0, negative 2. And we can also confirm that the graph crosses the x-axis at 1/3, 0, and negative 2, 0.